Hi, everybody. Thank you for being here this morning. As you know, Thales is strongly engaged in a digital transformation where AI plays a role of one of the crucial pillars of this digital transformation. The other pillars being big data, IoT and connectivity, and cybersecurity. So the difference of what Thales is doing in AI with other actors, other players in the same domain, is that Thales is operating in critical systems. And this is a very important thing. This is a very important differentiator. And AI is a long-lasting story in Thales. It's not new, actually. It's just accelerating now. It's a story which has started more than 30 years ago, and there are many products of Thales which actually involve components of AI technologies. People don't know this, but all along these years, many results and many concrete technologies, AI technologies, have been involved in Thales products and solutions. Now we are accelerating. And we are accelerating in a direction which is the direction of critical systems. Systems where lives are at stake. It's not the same when you download an application on your smartphone and you test it, it works, it doesn't work, so it's end up to work, so that's okay. But now if you are taking a flight, for example, provided that 2 planes out of 3 in the world are monitored by Thales systems. So if you are in a flight and that the monitoring system involves AI technologies, it's very important that you can trust these systems. So trust is the key word in the approach we are having in AI development and AI research we are doing in Thales. So what does it mean to trust an AI system? You just keep in mind 3 keywords. The first keyword is explainability, is to have systems which are explainable. At least a posteriori, we should be able to say why a system decides to do what it does, or why a system is recommending such or such behavior, for example. If you have a digital co-pilot in a plane, for example, if the digital co-pilot recommends to the pilot to make a left in 30 miles, so the pilot should be entitled to ask a question, why should I do that? Especially if the pilot had in mind to do something different. So explainability of AI systems is one of the pillars for the acceptability of AI for critical systems. This is very important. And what we are targeting is not only to be able to explain a system's behavior a posteriori by an expert, for example, saying why the system does what it did, but to be able to have such an explanation in real time when interacting with the system. So to have a kind of intelligent dialogue with the system and to be able to ask any system in the critical decision chain to ask the question, why should I do that, or why are you recommending such or such decision or behavior. The second point is the validity of the system. I can call it also the safety or robustness of the AI systems. An AI system is designed to achieve certain tasks, and it's very important to prove formally, to give a real proof that the system will do what is meant to do, only what is meant to do, and all what is meant to do. Just as in justice, the truth, all the truth, and only the truth, because you can have systems that can achieve a part of what they are meant to do, not all what they are meant to do, or also they can achieve all what they are meant to do, but also something else, which means that systems could do just non-desirable things. So validity of AI systems is the second crucial pillar for trust. The third pillar is responsibility of the systems. Just to make sure that the systems will behave the way they are expected to behave according to laws, for example, to standards, to ethics principle. And we are also targeting to design systems where the ability to implement ethics principles, for example, is by design, is native in these systems. So these are mainly the components for the trust we would like to build within the AI technologies. Now, if we look at the technologies, the AI technologies which have been making the buzz, which have been making the hype so far, we can ask the question, are these technologies really designed or able to meet such requirements, such strong requirements for trust in AI? 2 years ago, I gave a conference, I remember, the title of which was, is AI Spring going to keep its promises? It was a little bit provocative in some way. And as you know, AI is not a recent discipline, and it went through at least 1 or 2 winters, as we say. And it's normal to ask the question, are we on the right way? Are we on the right trajectory? Is AI technologies are going to keep what they are promising and to meet the expectations they have generated? The thing is, if we look at the current technologies, I mean the image recognition technologies, the speech recognition technologies, the technologies which are applied in games, for example, these technologies are basically pattern recognition technologies. All these technologies which are based on data processing, as you know, like machine learning, deep learning, and they are performing so well. They are even outperforming human beings in many domains, especially in image processing, in the medical domain, for example. The AI technologies are really doing better than what some expert doctors or radiologists can do in analyzing or interpreting image in this case. And one of the reasons, for example, is that just the human eye, the human retina, can distinguish around 15 nuances of gray, for example, while an AI system is able to distinguish thousands of nuances of gray. So just outperforming completely what a human being can do. So now these systems are not necessarily on the right way to some cognitive behaviors such as reasoning, such as common sense, such as human AI dialogue, for example, having a natural dialogue with the system. And we are entitled to ask the question, is there a continuum between these technologies and what we are targeting in order to meet, for example, AI, trust in AI, as I said before, or is there a glass ceiling? And so the answer is not strictly yes or no. I mean, it's not this option or the other one. It's a little bit nuanced, but anyway, I would say that there is not a continuum, really. So this is why we need to look at another part also of AI, which are not necessarily these data-driven technologies, but AI which is called model-based or symbolic AI, where cognitive behaviors, for example, reasoning and these kind of things, could be much more, I would not say easily, but naturally addressed by these technologies. And the virtuous trajectory is a hybrid AI, something which is combining the two approaches, the data-driven AI and the model-based AI, in order especially to build explanations, for example, as I said before, and or to prove the correct behavior of a system. And this is the kind of technologies Thales is working on right now. We are addressing, of course, data-driven technologies, AI technologies, machine learning, deep learning, as you know, to do image processing, for example, signal processing, and these kind of things. We are doing model-based AI in order to address decision-making in some cases, and we are now tackling and focusing on hybrid AI, AI which is combining data-driven and model-based approaches. So the challenges now are, of course, how to qualify, for example, AI systems. How to prove that the AI systems is going to do what is meant to do. Another challenge is how to qualify databases which are used to train a system. As you know, you take any corpus of data, there are biases in this corpus. So you need to find a way to balance this corpus in order to minimize the biases, for example. This is a real challenge. The third challenge is that in many cases, big data is not that big. It's rather small. So you need to build AI systems which can be trained on the basis of small data, of few data. And we are addressing a challenge which is called frugal learning, for example, in order, even in some cases, it's what we call one-shot learning. So just you show an example to a system, and the system is able to learn the model on the basis of one example, for example. So this is a real challenge also for us. Another challenge is the human-AI dialogue. How to build systems which are able to interact in a natural way with a human being. In natural way, which means language understanding, language generation, which is different from language understanding actually, and the ability to do reasoning in order to calculate the right answers, the cooperative answers, the system is able to provide to the human being, to the pilot, to the operator, you name it, anyway. And language understanding is not necessarily natural language understanding. It could be multimodal language understanding. In a cockpit, for example, where you have a pilot asking a question, could you zoom on this area, for example, by pointing out a screen, for example. So you are combining two modalities here. You are combining language modality and direct manipulation. And the system has to understand this multimodal language and to make a fusion of the two modalities in order to extract meaning from what the pilot said. And the answer, the language generation, is also a challenge per se, because a system can have very good things to say. If it doesn't know how to express these things, it's just useless. So an explanation, for example, has to be context adapted. It's very important, depending on the cognitive load, for example, of the operator. The system would not provide the same kind of explanation. And keep in mind that explaining is identifying the human level concepts that can be understood in the right context. We will not provide the same explanation whether you are talking loosely with an operator or we are recommending something to a pilot who is in a very strong cognitive load, for example. So human-AI dialogue is a challenge, is a real challenge for trust in AI. So this is also a topic we are focusing on in Thales, because interaction with humans comes within all our business verticals, whether we are in aerospace, in space, security, defense, or ground transportation. You identify any application, you will find the necessity to have a human interacting with AI in this case. So as a conclusion now, I would just underline the fact that data are assets. necessarily. You can hear this kind of things everywhere. All people are talking about data, saying that data is a new oil. I just heard recently a data scientist saying, oh, if data is the new oil, why I'm still poor? So this is just kidding. But the message here is that, of course, data is an asset. But what is important is that domain knowledge is also an asset. Keep this in mind. I mean, and the future is probably the combination of data and domain expertise. And in a company such as Thales, domain knowledge is very important. Is there. We have many experts in all our business domains, and we are using this expertise also to design AI systems. The second message I would like to send here is that AI is not a threat. AI will help humans to make better and faster decisions. And this is also the way we are approaching AI. And in many cases, instead of talking about artificial intelligence, we'll be talking about augmented intelligence. Okay, AI, which means augmented intelligence, how to help human beings to behave better in the critical decision chain. The third message is doing AI in a context of a B2C, business to customer applications, everyday applications. It's a certain kind of AI. Doing AI for critical systems is something different. Critical systems are very demanding, and we need to build this trustable, and even certifiable AI in a proven way. I mean, in a scientifically proven way. We cannot just say, okay, you can trust our system. So we have to prove this. Okay, and just as the very conclusion of my talk, I would say that AI is also posing questions to the human society. For example, as far as ethics is concerned, never human beings have thought about their behaviors, ethical behaviors, as when AI has come now. So every day we are asking what would an AI system would do in such or such case. And of course, it reflects the question to human beings saying, what would we do in such or such case? I will stop here. Thank you very much for your attention.